Okay, so this video contains the explanation on how to solve this particular problem. This is actually finding the limits by analyzing a given graph. Okay, so before we answer any of the items, we need to recall first how do we get the limit as x approaches a particular number. Okay, the key idea in getting the limit as x approaches a particular number is that you should take note that the limit as x approaches a particular number from the left, so any given function, must be equal to the limit as x approaches that same number from the right of the given function. Now if these two will be the same, then that's the only time that the limit as x approaches a number can be identified. Actually, whatever the limit as x approaches a from the left and whatever the limit as x approaches a from the right of the function, when they are the same, that will be the value of the limit. Okay, so keep that in mind. If you want to get the limit as x approaches a particular number and you want to analyze a graph, you have to check what is the limit as x approaches that number from the left and the limit as x approaches that number from the right. Okay, if you keep that in mind, it will be easy for you to identify the limit as x approaches a particular number. Okay, so let's look at these items. The first one is we want to get the limit as x approaches 3 of the function. So the function is already graph here. So you don't have to identify the equation of the function. So we know that this is the graph of the function f of x. So the first question is, what is the limit as x approaches 3? So your x is approaching a number which is 3. So take note that 3 is here. So to get the limit as x approaches 3 from the graph, we have to identify what is the limit as x approaches from the left. When we say x approaches from the left, the numbers are getting nearer and nearer to 3 from the left. And when we say x approaches a number from the right, in this example it's a 3. So you have to check, or the movement should be from the right of 3 until you reach the 3. Okay, now as you move or as you approach the 3 from the left, you have to trace the graph as you approach the number 3. So the graph is also moving along this path, and by the moment you reach the 3, the graph stops here. And when you look at the y value of that point, the y value is 2. So that is actually the limit as my x approach the value 3. The graph is moving down and it ended up with the y equals 2. So in other words, you can think of limit as the y value. What y value are you approaching as your x approach a certain number? So the graph, the value of y, the graph approach the 2. It stopped at 2. So the limit 3 from the left. So the limit as x approaches 3 from the left of the given function is equal to a 2. And in the same way, if I approach my the 3 from the right, you follow the graph, and then you also ended up with a certain number, the same number, which is also equal to 2. So the limit is also 2 when your x approaches 3 from the right for the given function. Actually, these symbols, when you just look at the graph, it simply means when the graph are connected. Say from the 3, when you look at the graph and they ended up with the same number, then the limit of the function as x approaches the number is that y value. So it's the same, it's 2. So the limit as x approaches 3 they're both the same from the left and from the right, they ended up with the same number, the limit of this is equal to 2. Okay, now it will become more interesting when we take a look at some of the numbers, because you will see, because here obviously they ended up with the same number. But let's take, for example, let's go to 5. Okay, so how is limit as x approaches 5 different to the first one? So I want to see, so limit as x approaches 5 of the function. So as I approach the 5, the graph is moving, and then at the moment you almost reach the 5, it seems like the value is a 4. The y value approaches 4 from the left, the y value approaches 4 from the right. Then the limit as x approaches 5 must be equal to 4. So this is 4. Okay, now in letter C, we want to get the limit as x approaches 1 from the left. So this is the 1. Now take a look at this. As I approach 1, the graph is moving down, and then by the moment it's at 1, the value of y is 2. So from the left, the value of the limit is a 2. Now there's a different story when you check the limit as x approaches 1 from the right. So note the graph from the right when you approach 1 is following this path. Okay, so as we approach the value 1, the value of y approaches this number, and in the y-axis this number is a 3. So the limit as x approaches 1 from the right is actually 3. So if I ask you, what is the limit of the function as x approaches that number 1? Now go back to the idea that the limit of a function as x approaches a certain number will be equal to a number provided that the limit as x approaches from the left and from the right are the same. So it says here that the limit as x approaches 1 from the left is 2, the limit as x approaches 1 from the right is 3. They're not the same, so there's no way that you can determine the limit as x approaches 1, the number 1. So we can just say the limit does not exist. You can shorten this answer by just writing D and E. Okay, so the limit does not exist because the limit from the left and from the right of that number are not the same. Okay, so that's how you analyze a graph. Keep in mind, you just check what is the limit from the left, what is the limit from the right. If they're the same, then that's the limit of that as x approaches that number. If they're not the same, the limit does not exist. Okay, for very simple, like letter A, it's very obvious. The graph is meeting the same number from the left and from the right. Definitely the limit exists, and that is the number. In this case, it's equal to 2. Okay, just to summarize the idea, this is the key. What's the limit from the left? What's the limit from the right? If they're the same, then that's the limit. Okay, so I hope the video helped you to understand how to analyze limits given the graph of a function. That's it.